Yes. So this is your work, eh? Yes. How did you calculate this? You did it the same way that calculating the dead load. You did it the same way, also.
Yeah, I used the ones which we calculated.
Let me first check here. Let me first check the load. I've already seen one header here, which is occurring first come later. Impose the load. No, you have not loaded imposed.
Imposed.
Hey.
Me, I stopped where we had stopped.
The one, you remember the one we got from Eurocode?
The two.
Yes.
It is there. Service. You check on service.
Service cannot be. Service is always one. In case you have to load, but you don't load.
Yeah.
It's too good. You see, this is this. This one now you remove it. Come to delete. You understand? So you come here. You come here and click on impose. It's either imposed or dead load. Those are the two loads that you load on the structure. Okay? You come here and click on imposed. And you go to loads. Okay? Then you go to level loads. When you go to level loads, you come and click here 2. Come here and click 2. Okay? You're going to click here 2 kilometers. That is what? Imposed.
So imposed and the service, which one? How are they different?
That's right. So that one is service is like serviceability load. Eh? Serviceability load is what? Is a type of load due to how can I say? Serviceability load. Okay, let me first explain for you imposed. Imposed load is a kind of load which is being which is spread of
acting on.
It's like acting, yeah. It's like irregular, like spread over the surface. You know, not it's like what variable. Understand? For example, you take a classroom. If you take a classroom, a classroom can be containing like 50 students. Okay, you design for a classroom which contains 50 students, but of course it's not a must that all the 50 students are going to be in the classroom. You understand? Sometimes other students may be leaving the school because of school fees and other things. You know, they go home or somewhere. You understand? So they will leave the classroom. They will not go there. So out of 50, you may find 30 students will go there. Will go attend classes. The next day, you may find 40. So it's just a variable. It's not uniform. You understand?
So imposed load, does it mean it is the load due to the purpose of that building?
Now the purpose of the building, like imposed load is, yeah, as I said,
like parking or school, like you said.
It caters for the purpose of the building. Which kind of building are you constructing it? Eurocode specifies each building to have what? Different imposed loads. You understand? Depending on, for example, you can't design a structure like for church congregations and a residential structure, or like a stadium and a residential structure using the same loading. You understand? Remember, a church a church can be accommodating very many people. A church can be accommodating very many people, but you see like a school or like a residential, you can have like maybe four people in a room. You understand? So maybe if you take if one person is carrying like 60 kgs, when you convert it into kilonewton, it's like zero. Is what? Multiplied by 9.81, you are getting like something maybe not much, like 120 or something in kilonewtons. Okay. Then if you divide by 100 into kilonewtons per meter square, no. If you divide by 10,000, is it 10,000? Square meter is how many? If you divide by square meter, you're going to have some small value, like 0 point something kilonewton per square meter, of which if a person is carrying 0.2 and there are four people, that one can be like 0.8 kilonewtons, which is on worst case you have taken 2 for residential, which is very good. So you can't take, so like for example, if a church is having like 20,000, like no, that's too much. If a church is having like 300 people, you multiply by what one person carries, like 0.2, something like that. You may find it's going to be having a much loading compared to this one of this one. That's why it's being given different. It's being given different first weight. But your value first weight. That's why you find it's being given a different loading, the life load. Okay. Yes. So a serviceability load is just like how can I say service? Like you can hear service. You know what I know is the serviceability load is 1. When you go to it's ULS, ultimate limit state. Serviceability is under ultimate limit state of a structure. The ultimate limit state is okay. I don't have too much clue on it, but I can understand it. But let me find a way of explaining it to you later. Okay. Let me find a way of explaining it to you later. I have a clue on it, but I can't make it clear.
So the ones which we are getting from Eurocode were the imposed ones.
Yes.
The QK we got from Eurocode are the imposed.
The QK. The one we got from Eurocode for residential.
They were the imposed load.
They imposed, yeah. They imposed.
Okay.
They get imposed from there. Then
we calculated the dead load.
I think I remember telling you a building has what? A building has an imposed load from the roof. Okay. I said it ranges between 0.0 to 1. So for us, we are using 0.75. Just come and put on the roof. You understand? I expected that. 0.75 for the roof, 2 kilonewton for the second floor, and the 2 kilonewton for the first floor. You understand? Yes. That's the complete loading I'm expecting from you, but your work was okay. Let me check the size of the column that you have listed. That is the column of what?
250 by 250.
As passed. You have 200 by 350 depth of beam. And then you have a slab thickness of what? What slab thickness did you use?
200 and 100.
One will be okay, that's the one. Now that you have this, then you will come to this one, the dead load. What is this 10 kilonewton, 10.4 doing up here? Are you going to put a 3-meter wall on this?
I've just remembered. I've just remembered. I was supposed to put that imposed. You have put that QK for 0.75. Then I just put that one maybe.
Just remove this guy.
It was supposed to be the other survey, the other QK.
Let me see. Yeah, you only put the dead load along the line of the beam where the wall sits. Okay.
Maybe the question.
Yes, yes.
You see, you go on load. You click on load.
What?
You first click on that load tab.
The load.
Up. No, load. Yeah, up.
Hey, I go to load.
Yes. What is that? Do you see that there is the level and the slab? We slab.
Hey.
When do we use a slab and when do you use level?
I think
when you're loading that, it may be like that panel, those like that slab.
Now, this one of slab, this one of slab is now when you are loading a slab individually, like you want to load this slab specific, you load this one and you load this one. So like you understand? Now for level load, you load a slab whereby this slab will cut the same way as this one, So for level load, it sprays everything, but for slab load, you may find this slab is having different loading. This one has different loading, this one has different loading. Understand? Now this one of area load, this one works after you have specified the area it is to load. For example, from here to here, if you know the length and also from here to here you know, then you come and use the area load. It will load for you exactly the area here. You understand? Yes, yes. This point load now it loads like at a certain point, like very straight point. Or maybe at an angle. You understand? So for wall you use full UDL. Okay.
Okay.
So this is okay. Let's first see. Now, of course, did you validate? Yes. So when you click on validate, say your work is okay now. You are ready to what? To go and do your not analyze, man. First go and do what? From here you come here. I think last time we stopped here. So now today we're going to design. We're going to design. Okay. Then from here, if you wanted the next thing now you're going to do is to do what? You're going to do the load combination. Okay. If you want to go and do load combination, to come here, still under load, you go to load cases. Click on load cases, okay? Under load cases, you go to combination. Are you seeing? Load cases, under load cases, you come to combination, okay? Then after clicking on combination, you come down here, you're seeing down here to generate if you have your own combination that you want to use, you import. But if you don't have, you just generate. You click on generate. Okay. Yes. You leave everything untouched here, like on this interface. You leave everything untouched. You come to scenario. You come to scenario. When you reach scenario here, you click on the drop key button. Then you see there are different scenarios here. Number one, we have operating. Now, this operating, it means like it's a scenario where the building is in a full operation. Like if you have if you have designed this building to carry an a dead load of 2 kilonewtons, you are saying at that point the building is carrying a dead life load of 2 kilonewtons, and when you have designed it to carry a dead load of 10.4 or over the entire length of the beam, it's going to be carrying that one. So when it is in full operation, like when it is at its maximum loading, you understand? Yes. So when everything that you are designing for is on the building, so you're designing for that worst case. Now, the final. Now, this final is saying maybe when you are you have now reached like you maybe let me say you're like constructing the structure. You have started constructing it phase by phase by phase by phase up to the final stage. Then the third one, that final stage is without the loading of maybe people entering there. So now this erection is when you're still in the process of raising the building. You understand? But now the one we're designing for is when the building is already in operation, like in full operation. You have erected it, and you have reached the final stage. Whereby you, of course, for the final stage is when it's now ready for commission. Not yet with loading, like people have not entered in it. So that the weight of the people, the load being imposed there by the people entering there is not yet there. Now, fully operating now, it means people have not entered the building. Everyone is there now. If the building is to accommodate 50 people, all the 50 people are inside. That is under operating. So you design for the worst case scenario that is operating. When everyone is like, when all the necessary things required are there. Okay? Yes, then you just under here you come and click operating. Okay? You click next. Under combination, we have these are the combinations that we have. The one they generate for you. This is then the partial factor of safety. Then this one here also. This one for the factor of dead load, and this is the factor for imposed load. You go next. This is still under what? Now you see the serviceability. The serviceability load, it's here. Like for it is here in the system, like you understand? Yeah, serviceability load is 1. So that we can't exceed 1. It's always being accounted for, even though you don't load the other side, it's accounted for in what? In the in the combination. Okay? Yes. So now this serviceability, you come and check this. You come and check all these boxes. Okay. Then click finish. Okay. Then after clicking finish, you come up here. You say okay. You get it? Then if I come down here, I click on none. Then where? Give a second. Okay. So there you're done with your serviceability loading. So the next thing you come is what? You come to design. Okay? You come to design, then you come to design all static. Okay, you can come here to the settings first, click on the settings and do some simple setups. Okay? Right now, what you're designing for is what is a concrete structure. You start, okay? You start the nominal weight of concrete has given you here what you start with the beam, okay? Under beam, yes, you start with under beam. You're designing for UK, that is Europe. Yes. Then the maximum bar, the minimum bar size to be used in the beam, the one you're saying you're going to be using here is what? The minimum is 12. The maximum I can use for this structure here is let me say 20. Yeah, maximum. I can say the maximum is 20. Let me say 20, yeah. Then the grade is there. The rib type is type 2. You say, okay, you have seen it. Then the minimum side bar, I'm using that. Now the spacing, it also specifies for you. Okay. Then the detailing, you can also come to detailing. You check here, you do settings here, the bottom reinforcement bar, which are these ones here. The link settings. You see the link settings, the minimum spacing are 100, the maximum spacing is 300. So it means you are restraining your design. Like when it's designing your structure, it's going to design it within that range. You understand? You come to column, they are saying the minimum bar you are going to use for column is this, the maximum bar you're going to use is 32. But me, I'm going to say the maximum I can use is 20. The spacing is there, they can remain like that. Detailing setting. The cutting length, everything here is okay. I come to slab. Yeah, the minimum is there, the maximum bar length is 12 millimeters, 12,000. So these are the things you just do. I'm setting simple.
You have changed to Europe for one element.
Eh?
You changed it to Europe for one element, and the rest are in UK.
UK and Eurocode are the same. Yes, they are the same. They use the same book. So I click save. I say yes. Then I click OK. Okay. Then I go to design all static. When you click on design all static, you wait and see what is going to happen. Wait for your call. Wait. Can your building survive? Can it survive?
It can't fail to survive.
Can it survive? Your preliminary member sizing, the one we have used, can it survive? Yes, yes, yes. Have you now seen the preliminary member sizing is very important? Preliminary member sizing is very, very important because number one, it's not accurate, but at least it helps you to know this could be the size of the beam, or this could be the size of the column, this could be the size of the slab. Everything has passed.
Yeah.
You have seen, eh? Everything has passed, everything. You see green, everything has passed. You go to slab, where everything has passed. Okay? Now come and check the status. Yeah, everything has passed. You can check the ratio of which, not here, status, yeah. That's where. Well, we have the ratios here. Let me first check. So let me go to what? Report. Is it the report draw window review? What to review? What do you want to see? So now, if you want to see how your thing has passed, now you first click on this column, right? Like, let's take this column, okay? Want to see how it has passed. You right click. You right click on it. You understand?
Yeah.
Then you go to interactive design. Okay. Then you go to static. You come and check how your column has passed. Here, utilization ratio is here. Okay. This is how your column has passed. They are saying this column over here is here. This is the column section that it is what 250 by 250. Okay. Understand? So the intermediate bars that if it's H12, but we are using this is the section we are using 4T16. So come and check here. The loading at the bottom of this column for this specific one, the loading at the bottom of this column is 10.9. Okay. The moment is what? Is 3. The moment the resisting moment is 32. So the resisting moment is greater than the moment that we that cause deflection. So from the class, they say when MED is when MED is greater than the MRD, it implies a failure. So always MRD has to be greater than what? The MED. Okay?
Yeah.
So we have this guy. We have MED is 3.0 bottom. Then M of the moment resistance is 32. Even for the top, it's so good. The ratio, the utilization ratio is so kawa. You can check. The ratio is what the column can carry. The utilization ratio is what the column can carry. Here it shows that it has passed. Let's wait. You go to the links, check how the links is spacing. Yes, the link is we have a spacing of 150 millimeters between the what? Between the links. And they're using H8. Just passed. Then you go to the interactive design diagram. So now for this diagram, the N and M interactive diagram. This diagram for it is also like the average design force on this column. The design force we are having NED is 522 for this column. The moment the MED, the MED and the major axis, the major axis is 2.9, the minor axis is down here, that one coming down. So what you should know is from this when you design your column, this is like number.
The network is bad. Your network is poor.
Why? So this is the current.
Yes.
Are you getting me?
No, your network is on and off.
Bill.
You can even see on your computer they are telling you lost your network.
Yeah, I'm seeing here.
Mm.
And we have network that I've moved somewhere like I've moved to some room here. We have other students. The other
It was
side.
okay, but it has started going on and off.
So it's okay. Oh, Bill.
Yeah.
Yes, Onesmus.
Yes.
Just come back.
Yeah.
Okay. Yes, we go back. So I was explaining.
Mm.
I was explaining like now. This one of N and M interactive design diagram, interaction diagram. This one shows like the major. I mean this is the M, and so it's along this what along the shape you're seeing here. This one shows like how a column carries the load. You understand?
Mm.
So if you have seen this star here, this one shows the midpoint is like the axis of a column. So this axis of a column has to be within the circle, like to show the carrying capacity of a column. Whether a column can carry the specified loading. So if this thing in the middle here, the dots and if it has moved out of this 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 shape,
Mm.
it definitely implies that your column has failed. Okay?
Mm.
So always your thing has to be within, and it will not even move like somewhere. If it has moved here, it means your column is likely to fail. You understand?
Yeah.
Yes. So interactive design is the core, the head of design. You understand? You can design now. It's from interactive design that you will save a client, because you are going to over design your structure or you under design your structure. So it's through the interactive design where you are going to where you are going to at least correct on your things. You understand?
So when it is out now, you increase the size of the column, or you do what to bring it back?
Increase the size of the column.
Uh,
Yes. I hope you have understood.
Then this one, yeah, those are two different sections. Eh?
These are two different sections, but almost doing the same stuff. The same stuff. You can check. Now this one, you see from here. Are you seeing up here? CS, this is the column 25, 1, column 25, 2, column 25, 3. So this one of 1 is the one at the bottom. Remember this column, we have 3 columns, 2 floors. So this one is the one from the bottom, this one is the one from the middle, and this one is the one from the top, okay? Let's start with the one from the bottom. You can see the utilization ratio of the one from bottom is 0.153, okay? So this one carries 0.153 loads, and the NED is negative, it goes down. Because let me see, okay, let me consider this. 0.15, this is the utilization ratio, okay? So you will come to the next one here. 0.154, it's slightly similar to almost this one. What the midpoint column and the bottom column can carry is almost similar to the one, or the one, they are almost the same. But now this one is the top one. Remember, the top one is the top column is only carrying a roof load. So the utilization ratio is very, very small, 0.095. It's just even less than 1. Okay?
Yeah.
This loading is small. You understand? So let's click OK for that column. Eh? You have understood, eh?
Yeah.
Let me check on another column also. Let me take this column. Yeah. No, let me not that one. I wanted some column here. Like this one. This one. Where is it? 5. I wanted this one.
That one.
I right click. I go to interactive design. I check. Okay. Yes. Now for this one, are you seeing the bottom column is carrying 0.76? This is the one for the bottom. So it means its utilization ratio is too much, like it carries too much load compared to the one in the middle. The one in the middle carries 0.496. Then the one at the top carries 0.2. I think I explained for you what a utilization ratio is, the carrying capacity of a member.
Yeah.
In form of a ratio, a total ratio is 1. Okay? Yes. If, for example, if we are to be given
roads,
a load, what?
A load to carry.
A load to carry. If I are to be given a load to carry, like me, I'm 50 kgs, and you are maybe 70 kgs. So if you're 70 kgs, me, I'm 50 kgs. But if they tell us to carry something of 50 kgs, okay? For you, out of 100, the 50 kgs out of 100 is what? Out of 100 is 50. For you, out of 100, your 70 is 70. So if you convert that one into percentage, it is what? 0.7. Okay? The percentage yours is 0.7. So mine is 0.5. Okay? But the load, that's my load, personal load. So the load being given to me to carry, okay, out of 1. Remember, I'm given I'm given 50 kgs to carry, and I'm also weighing 50 kgs. So it means on ratio, the ratio is 1:1. So it's 1. I'm full. Everything, like my carrying capacity is really overwhelmed, like full. So my total ratio is 1. It means I'm like a prone to failure. For you, you can carry because you're 70, so the total percentage is 1. So out of 1, for you, you're carrying 0.7. Okay, you still have ability to carry 0.3 to make it 1. You understand? Yes. So it means you are still able to carry. So it means now when you look at column C1, C1, it is carrying 0.766. Okay. Now, for you, if any load is being added to this column C13(1), these two other columns won't fill it. Okay. But if they add a load on column 2, still 1 is going to fill.
Yeah.
Even though they add to 3, 1 is going to fill. So all the loading. So this one of 1 adds up all the loadings for this one and this. You understand? Okay. So always your eyes should look at what this one. There's two way. That this one in the middle can carry load more than this one. How? It's not possible unless it's possible when it comes to sizing. Maybe here for 2 you give a small sizing, where by the other side, for the other side you give enough sizing. So if the sizing is different, it's possible. Understand? And let's check the sections. You can check here the bars. Now here the bars they have used is 20. I don't know why 20. Yes, they have used 20, but if I'm trying to use 16, it's failing. I'm trying to use 16, it's failing. I said 16 is failing, then 20. I say, now here, this is where thirds come in. Thirds is so nice. That's where thirds come in, interactive design. You see what I was saying? The thing is now out. Its part is out. Now you see also this other. This X is out. You have now seen what I was saying.
Yeah.
The X is out. Here it is also out. So it means actually these figures you're seeing here, the figures you're seeing here, the NED and M is just a figure being plotted from the graph. You can see the NED we are having here. This is a moment diagram. This is a moment graph, and this is what a force, like the force, the shear force. And this is the force and the moment. This is for moment. It is kilonewton meter. This is in the kilonewton. Okay.
Meter also.
Yes. So for the force, the NED, you get it from here. Okay. You see, this is 904.6. You come here, 904.6. If you pick it from here, you just read it like the thing is source for you here. Then when you drag it along here, you see up is 9,000. It's 1,000. So it means that the one we are having is along here, up here. I think you can see. It's just just here around here, which is 904.5. So now, if you someone who is wise, Now you have this value. For example, now if you know to use TEDs, start TEDs, you now pick this value, which is 904.6. You take it TEDs to design for your column, and it generates for you a structural report. You understand? Pick this value, and you have your CFOs of 4.5. You take this CFOs also to the what? To the TEDs. And you calculate your thing. The moment you're having here, the moment the MED is negative, the CFOs is also having their 2 negative. The moment is also negative moment. We just go and use the moment of 0, 0 because this is negative. The CFOs, something like that. The CFOs is 4.5. You go there, punch your things in the computer. It will be good to go. But I'll show you now that you have seen this. Later on, when we reach TEDs, I will show you to get from these values you've seen. You understand? Going to use them. Let me come back here. This is the links. Let me come. This is the links. I come back here and I change my thing. Where I change to 20. Change to 20. 20 has passed. I go back to interactive design. Let's come back. The force is still the same, but the surface area has increased. You understand? So now the of the column is around. It's able to what? To safely transfer the load into the ground surface. You understand?
Yeah.
Yes. That is the very, very most important thing you need to understand. This is what is called interactive design. It's now from here whereby if the loading, if the software is over designed for your structure, you can adjust now. You say now, maybe you see I was adjusting to 16. For example, you may find a software can do for you in 20 now. Say for it saying 20 is too much because of the spacing. 25 is too much. Maybe if you say 20 for 20 it has passed. Sometimes it can be refusing for you the big bars because of what? Spacing issue. Yeah, if the thing is closely spaced, of course, it will be very, very hard for the aggregates to pass through the small space, and later on you will be having a honeycomb setup.
Yeah.
So your column won't be very, very strong at all. The bondage between the concrete and the reinforcement won't be too sufficient. Later on, a building failure, or maybe the building won't reach its lifespan. Understand? Are you good with interactive design of column?
Yeah.
You can still ask later on, because this won't be the first building that we are going to design. Come here and click OK. Okay. Yes. Now, still from here, that you can now generate, like you can show the member loading. Okay. The loading is a structure. We have these are the how. This is stack 1. Stack 1, the loading is there. Stack 2, stack 1 is the first one. The direction is global Z. The global Z is the one which is the what? The negative Z direction. Global Z, it's along this, it's along here. Like when they talk about global Z, they are meaning something like this coming down. This is the global Z. Okay? So it is an actual load. Yes. So you can see, you can close here. Again, you right click and open the load analysis view. Okay. Yes. This is the CFOS diagram for this structure. Okay. You can see at the base, it's having a CFOS of 61.3 kilonewton. at the base. So the shear force at the base for this structure is too much compared to the one at the first floor. You understand? As you keep on going up, the shear force reduces. Okay? This is for column. The maximum shear force for a column is at the base. Okay? It's at the base. The bending moment, you check the bending moment. This is the bending moment. Okay? This is negative, this is a negative. So a bending moment. So a bending moment is shows like how your structure is likely to bend, like how. Okay, and a structure doesn't bend from the base; it bends in the middle point. You understand? That's why you see at the base you have the negative 0.1 kilonewton meter. Up there is also negative 0.2. So it's likely to bend from the midpoint here. It's likely to bend. So it's likely to bend from here. You understand? So that cannot bend from the base. It can either bend. Actually, it's also very, very hard for it to bend from the top. That's why you're seeing a negative here. So it can bend in the middle always. Okay? Yeah, buckling, buckling occurs here. And from Eurocode, buckling for a column, where buckling to occur, okay, like it's called what? Effective height of a column for buckling, it's called H naught. You see? And for a column which has both ends fixed, like if you have a column here, then it is fixed here, it is fixed up there. For it, it's calculated from 0.75 L, okay, whereby the L is the total height of a building of what? Of a column. So if you have a column which is of height 3 meters, which is 3,000, your effective height of buckling, like where the column is most likely to buckle from, is 0.75 multiplied by the column height, which is 3 meters. So your column is most likely to bend from 2.5. Let me first get for you. 2.3, I think 2.355. You got to the 0.75 multiplied by 3000. 2.250. So your column is most likely to buckle at 2.250 meters. You understand? Let me say 2.250 is around here, okay? Of which it is like this one here. It's just like this. You understand? Okay. That's cover. So that is what we can. And about the major axis, absorb force, and the bending moment. Okay. So when still come here, I still have something to show you. Now you view member, you open member view. Okay, exactly. Now you have seen how this column carries the load. You have seen now the area, the tributary area I was talking about is this guy here now. This guy here is the one I was telling you, the tributary area. Okay. This is the tributary area that I was telling you. So that is how the column carries its load. it carries from 4 different sections. That is if at all the column is at the midpoint. Okay? That is how this is how the members are loaded. Plus the wall here, plus the wall that side, not going to the slab. Unless you just add the one for the wall, for the what? For the wall of the beam. Okay? Yeah. You also come here and check what member loading, member loading. That one we have checked. So come here. You can also produce drawing for this member. You can now check member, design member. Now this one, if you want to design it alone, you generate a drawing. You can generate a drawing for these members and let's generate and see. And I don't know what's wrong with my AutoCAD. I don't know what's wrong. If I try to open something, it can be refusing. If I'm going to open direct from Tekla, it will not refuse. It won't allow. It always refuses. I don't know why.
Which version is that?
First, I wanted to see how I can generate drawing. Because for it to generate automatically, like from here, if you go to generate drawing, use the Dell app. We'll call it. So it's there already. And then you go and open. That's great. And then you go here, it's there. It is on the user Dell app local temp C13. Okay. Then we go to user. Let me come here. Let me come here. I go to desktop. I go to user. I have a user here. Where is that? Am I having Dell here? You see,
You go to local disk.
become PC. Let me go to this PC. Here. Okay. User. Put Dell. After Dell. Is it app? App. Local. Come to local. We go to temp. Temp. Yes. Yeah, around here, I think. It's called C13, I think. C13X, the Excel file. Let me check here. Where?
It's there.
This is the guy. Oh, just one. It has to be always. Opening, let it open. I think it's opening. Yes. That's how you open it. Let's first wait and see how it opens for us. Yes, it has opened. Okay. Now, you see, this is what I was saying. You see, Tekla generates for you everything, like everything here. The moment you have set your things there, Tekla just generates for you everything, like not leaving anything behind. And the thing is just disturbing. The thing is disturbing. It's not settled. Now you see, it also bends for you the bar, locates for you here. Okay. Tekla shows that in here you have used the 4H16. And it also shows for you that from here up to this point, that you have used the 18H8 bar mark 5 at a spacing of 150. Then this section you're having here is here. Okay? It's telling you AA is H16. Then the dimension we have is 250 by 250. Okay? Then the B, at the B, you'll see B is the link. The link you're having is H8 at a spacing of 150. You understand? It can also pick for you that this column was picked from a grid reference 3 and 5. It's called CR, C1, D3, C. You understand? It gives you the what? The bar bending schedules that you have, the type of the bar you have used, the whole of them, like you have used the H8, which is the link, the weight of this link you have used, which is H8 is 0.39. Then you multiply by the entire length, the entire length is here. Then the total mass in kilogram, it also gives you. Even for this, it gives you. So now, if you a quantity surveyor, you use this value direct for your BOQ instead of calculating. Also here, it calculates for everything, the total length, the shapes. You understand? Now let's come here again. It shows for you. Here you also use the column of 350. Here, this thing shows that it is continuous. Here it is continuous. This is the story 3 SF. The story 3, the second floor, which is SF. What is it? Second floor. This is the first floor. The first floor, story 2. This is how it named it. We didn't change. It also shows for you the kicker. It shows for you the kicker, which is 75 millimeters. You understand? It shows for you the kicker, which is 70. It also bends for you your bar. This bending, it is what? It is a 50D. The bending is a 50D, but D depends on the diameter. If it is a 16, it is 800 millimeters. So you bend it from down here, 800. If it's 20, you also bend 50D. The same thing here. You have it there. So it's for you the base. You understand? It is source for you the columns of this kind. The columns of this kind, they are 9 in numbers. Okay? The columns which was designed to do this, they are 9 in numbers. You have seen it?
They are grouped.
It has grouped. So you see, For it, it cannot produce all the columns. You see, for Prota is going to produce for you all the columns. If you have 30 columns, Prota is going to produce for you all the 30 columns. Now you see Tekla is going to produce maximum is 4 columns. Maximum 4 columns if you have used different types of columns. So for it what? It can group them. So you see, for this one, there are 9 numbers. If we tap on another one, it's going to show also these numbers. You understand? So that is how the thing comes. Very good, very nicely. Okay. Now here for this one, in the AutoCAD now, if you are using direct, if you are doing it directly, what are you doing? Where are you wasting time? Only maybe you put this one aside by this column, it remains like this. You won't even edit something here. Unless on your layout, you are not using this column number. If it is CR C1, the column the number, then it's the thing you're going to change. Maybe you're using column C1, C2, not this other prefix. Otherwise, there's nothing to change here. You have the entire thing. You understand? Yes, directly from Tekla. So if you want to generate the what? If you want to generate the report, like the report from this column, I right click. Actually, first go to report, okay? Then I go to model report. I click on model report. So for model report here, what kind of report do I want? I wanted this is a column. I come here. I look for this is what building what. I come and I add. And I say here concrete. I say concrete column. Okay. I remove this guy. Then when I create concrete column, I click add, but my aim is this one, okay? So after clicking on concrete column, I come and right, I click here, activate. Okay? I click on activate, then I come and click, I make it okay. Then I run here, member report. I click on member report. Okay? I change here. What am I having? Concrete column. I click on concrete column. Okay? I click on concrete column. And it's telling me concrete column report, concrete column analysis, concrete column design. I come here. I click on it. I click on design summary. I start with design summary. I click, I drop it there. You understand? I come to interactive design diagram. I drop it there. I click.
Calculations.
Where calculations? Where design calculations? Yeah. I drop it there. Actually, I can remove this guy. Remove item. I remove that one. Shear cost diagram. I drop it there. Bending moment. I drop it there. Deflection. I drop it there. And then axial force diagram. I drop it there. Okay. That is if at all I wanted the drawing, design summary. Let me remove one. Remove item. You have this one, okay? Then I click OK. You understand? Then I click show report. It's not so okay. Let me go back. Let me go back. Come here. Then I click here. I right click. I go to member report. Is where a report for member. I click on it. It's generating for me. You see, it has generated for me all those things that I have taken that side. Okay. Like it generates for you all those things. Number one, the drawing for that column. It's here. I've seen the column is there. Here. Okay. Stock here. This is stock column. Stock one. Stack two. This is stack three. Okay. Stack one is the one which is carrying the most load, the biggest loading. Stack two, stack three. Stack one is this one. Okay, let's first check. Let's first check. Now we come here. It has now summarized for you everything. Here it has passed. Here it has passed. Now we come design stack calculation. The stack three now is the upper one. The upper one, you come and check the axial force. Axial force, the one on that column is here. We saw the bending moment about the axis. Remember what we have seen? Everything here it has passed. Then you go to ceiling has passed. And you go to stack two. Stack two, it's carrying 500 and something loading. Now checking here, it has passed. Now come to stack one. Stack one, now this is the base, okay? Base top critical eyes. We saw that it was carrying 904. This one, we saw it from the diagram there. Also, so if you are using tags, you just pick this one and put in tags and calculate your size of column or footing. You can check shear force diagram. Everything is here. You check. This is all what we saw before. So you see, this is a member report. Like now, if you don't know how to make a structural report, you just go and present this one, and it is a very good. It actually shows for you the exact thing. You understand? Yeah, this is the structural report. If at all you don't know how to show, you have it here already. Very good, very nice. Understand?
Yep.
So we have handled column. Let me close it. Let me close here also. Let me close it here. Let me close it here. Okay. Now let's come to beam. Let's start with this guy. You click on it, you right click. Okay. Then you go to interactive design. You click on static. Yes. You can see this is having this ratio you're seeing outside here is showing the maximum. It's showing what? Is it a zero ratio? Zero. Let me show you. Design and partition span. Okay. Let me first pick the first one. Okay. This is the first span. Let me check which one is the first span. Like, you see, this is the first span. This is the second span. This is the. Are you checking down here on my cursor? Like this is the first span. This is the second one. This is the third one, and this is the fourth one. That's all. So now, if you know that it's like that, you right click and go to interactive design. You click on static. Okay. So this is one, the small one, 2, 3, and 4. Okay. Yes. You see, if we go back here, here it is also the highest ratio. Okay? Like it shows the beam which has the highest ratio. So it designs for the one which is what is carrying the biggest what loading. So here the one with the highest ratio is 0.527. You understand that?
Yeah.
So you come and check here which one is carrying 0.57, 0.227. The first one, no, the first one is carrying the smallest 0.339. Smallest. The second one is carrying 0.5009. Ah, this is small. The third one is carrying 0.527. This is the, and along this beam, this is the most critical. Then you come and check here 0. Okay. So now you come and start. Let's start with the smallest size. And say the smallest size, they are saying you can check the bars. This is the bottom bar. This is the bottom bar, it's markers bar mark 8. Then this is the top bar. The top bar is being marked bar mark. Okay, this so you are seeing 6L and 6R. This 6L means 6 left on your left, beam 6 on your left, and this one means beam 6 on your right. Okay? Yes. Now this ones they are columns. This is a column. Like this one is a column, this is also a column, okay? Yes. So this one here, it is in 6L, and this one is in 6R, okay? Yes, yes. This one down here, it is a tension reinforcement, which is marked as 8, okay? Yeah. So it means you come up here. If you change anything from here, you're dealing with the 6L, which is this bar. Now, if you're changing something here, just know you're dealing with 6R, which is this one here. Okay? You understand? This is a longitudinal. This is longitudinal top bar. This is for top. You can even see that for top longitudinal, like there, you know. Yes. Top. This one, top bars. Then this one is longitudinal bottom. It's only 8 which is down. There are 2 of them. You understand? You have understood that, eh? Yeah. Let's start. Now, here, if we make, they are saying at the top, we are using 2H12 on the left-hand side, 2H12 on the left-hand side. This is what? Near this column. Near this column here that we are using 2H12 on this here. 6L, okay? Now on the right around here, we are using 2H12, okay? You understand? So you can check on one, we are having utilization ratio of 0.3, of which it's still able to carry 0.7 something. You say, okay, let me do it like this. If I change this one from 12 to 16, will I fail? Say, no, I'm not failing. You understand? It has not failed. You understand? Yeah. Is it? No. And then it's this one. If I change this one from 20 to 16, will I fail? I will not fail. You can see the utilization ratio here. Now it has moved from 0.5, from it was what? 0.3. From 0.3 it has gone to 0.5. It means now you have turned to 16. Let me add again. If again I use 12, it is now failing. Eh? It's 0.9 something. So you say, let me say, maybe you have to fail. But what if it's 3.16? It's not okay. Let me use 2. Okay? Let me use 2. But now let it be 16. Let it be 16 and see. Yes, it's passing. Okay? You understand?
Yeah.
Yes. Now, this is the bottom guy. The bottom, which is 8. Now, if I say I use 16, if I use 16,
So the 8,
it means this. Yes?
the 8 and the 6 are just labels or what?
What?
The 6 and the 8, are they labels or what number?
Which one?
That's 6 and 8.
6 and 8, these are the number of the what of the bars, eh?
The labels, eh?
The 6 are that's just labeling, yeah. They are labeled, these bars are labeled. Okay?
But
These are just labels to make you easily understand. 6. So this 6L on top here means that there are 2. Okay?
on both corners.
On both, like here there are two top. It means also here this 2 top T12. This here it is 2 top T16. Okay? Then we have side bars. This is saying they are side bars if required. Now, if you need side bars, you can put them here if required. But for now, the design is standing even though there's no side bar. You understand? Yes, it's standing. So you say, okay, here I'm sorted. You see 16, even though even though I turn it to 12, there is no effect. If I bring it to 16, there's no effect. Let me just leave it to 16. You understand? Then if you scroll down here, let me carry this guy, I take it somewhere there. Now you can even see the whole thing here. At the span one is this one. Eh? And this is 2. Top bars, eh? The top bars 1 and the top bars 2. Okay? This is 1 and this is 2, of which you can check the ratio. The ratio here. 0.520 here. Then there is what? 0.33. 0.33, I think, is the first one, I think. 339. Okay. The spacing, this clear spacing is 100 what. So you can see the area required. At first, the area they required was 277. We provided 226 in the past. Now, secondly, they wanted 209, the area, but now we provided 402. It has passed very, very well. Okay? Now the spacing, the area of the spacing they need here. Here it has passed. Everything has passed. The check is saying everything has passed. You understand?
Yeah.
That, eh? Let's go to the next part. Now, this one was the ending of the other one. This was the ending of the other one. This was the ending of the other one. This was the ending of the other one. Now this one. Now this is the beam. This is the beam of the form of the 4 meter, about 5 meters, about 4 meters. Remember, it started with the thing was like this. This one was about 1.5. This one was 4. This one was 4. This one was 1.5. Something like that, eh? You remember the beams? Like
yeah.
the space. The
it was
1.5
over 4.5 and 4 and then 1.5 again.
Something like that. Yes. Let me see now. This is what we have. Now this is about the 4.5. We start. Okay. Now,
yeah,
now here, the other bar now, this one, which is on the one which is joining the other beam. For it, it's being called now at this point now, they are calling it 1L, and this is 1R. The support, the one at the support, okay? Support, the one at the support. The 1L and the 1R. Okay, so you come and check here 1L and 1R. Then the one in the middle, the longitudinal in the middle, like the top reinforcement, the one in the middle, is for it. It's called 3. Okay? Yes. Now, the longitudinal bottom. First, wait, let me finish here. There's one left, one right, plus 3. 3 is in the middle. Yeah. Then we have the longitudinal.
Bottom, those are for bottom.
They are the one at the bottom. We have this bar which is called 8, and they also have a bar which is 7. This bar which is 7, of which they are saying 7 is not necessary. They are saying the count is 0. Okay? So this is now like the side bars, the one in the middle. But they say still here, it's not here, it is 0. Are you picking something? Let's start. Now, they are saying here, which is what? Let's start with this. We always start with and the support. The one starts with 1L. You start with 1L. They are saying 1L, they need 216. So 216, if I use 12, it's failing, okay? If I use here 12 at the support, it's failing. It's okay, let me come back to 16. This is what is called interactive design. You are trying to play around with the bars, like whether it will be economical, because you end up over designing your structure. Okay? Yes. So you can check here, the one and here at this point it has passed, it has failed in the one of, if you are considering 12, it has failed. So it means 16 has passed. Now let me come to the right. At the right is saying, and this support says here is a long span, and also here is a long span. For it needs 20. Let me come up. Right, 20 is the one passing. How about if I use 16? 16 is repairing. 16 is exactly 1. It's like exactly 1. You can see. They're saying 16 cannot go there. And if I use 3 bars cannot work, because T16 is big and the spacing will be what? Will be small. If I try 3, it cannot. Let me just use 2. 1 T20. Yes, and this support. But if you go to the field, most people, if you have designed this one with 16, they will also consider this joint to be 16. I don't know. But remember, there's maximum CFO supports. Maximum. You understand? So if they say we need to use here 20, it has to be 20. Like I check here 20. Okay? So here is 20 at this support, here is 20 at this support. But in the middle, I can use 216. You understand? Then this one is resolved. I come down, let me come down. Down here, I have a bottom reinforcement, which is saying 216. 216 here. If I use 216, no, let me check. Did I change? Because I'm saying the thing is still failing. Where is it failing?
It's supposed to be over 16.
Hey, this is 16, I mean.
No, the error.
Yeah?
You leave that one 20.
This one?
That's 16. You put 16 there.
Yeah.
20.
Check.
16.
Which one? Here.
You interchange them the way they are. The 20 becomes 16, the 16 becomes 20.
Yeah, this is 16.
Then the other one 20.
This is 20. No. Why is it? This one has to be 16. Okay, well, this is 20 for sure. Yeah, 20 has passed. 16, then it goes to link spacing. Link spacing is having a spacing of 200. It has passed. So, okay. What did I do for the, you see, all the beams have failed. What did I do for the beam to fail? You come back here, go to interactive design, I check. My beam is failing with the what? My beam is failing with the resistance ratio of 16, 16, 16. Let me come back. Okay. I start here with this one.
You see that one, the one which is the highest, 0.85 on the utilization ratio.
Yes.
The second last.
This one.
Yeah, the one with 0.8. The next one, that one.
This one. This is this one here. Like this one.
Yeah.
Yes.
On the bottom, the other side, on the bottom, maybe.
Bottom here. Yeah.
That one.
16. No. What is failing? Let me check. They are saying other checks. Which other checks? Everything is okay. Which other checks are you talking about? Which face have this? 20, 16 is failing. That is true. I use 20, 20 is passing.
First put 12 there in the middle, we see.
Eh?
First put 12 there in the middle, we see.
I put what?
12 in the middle, that the one which is highlighted.
This one.
First put 12 and we see.
This one is this is what? 1L. 1L is this one. And this 1L can only pass with the 20. Or if I try with 25, it can only pass with 20. 25. It has to be 20 at least. This can pass with 20. Then this side, this is last one. Last one is passing here 16, here 16, 6, left 16, here 12, it is okay. And it's also selling me this trading. How? What is there? Other checks. What do you mean when you say other checks? Other checks like what? Check. Check. It's telling me don't the no bus. Yes, here everything is okay. Then bending. Bottom area provided where everything is okay. I come to design some Russia. Everything is okay. And if I know it's a problem in this one. The smallest bar diameter in the region, minimum allowed longitudinal bar diameter, fail. Larger bar diameter in region, maximum allowed longitudinal bar diameter. So it's all about bar spacing, I think. It's okay. So
the problem is there.
We'll first count link spacing. If I use it here, 150. Take here, 150. Right here, 150. Still, I come here. The guy is still failing. And that checks. So it's about bar spacing.
The problem is on those two.
This is about bar spacing. 12. Okay, this is 16. 16.
Put 16. Put 16. You come here on this edge. Remember, we changed for them to fail. We had changed here on the size, this side.
Here,
So there. Try to balance those two.
16 has passed.
Then that one also. Make it like 20. First put 20 and we see.
Yeah, he has to pass. He has to pass. 16 and 12 for bottom, and he has to pass. Everything has passed here. He has to pass. You see, here everything has to pass. Here it has passed. Hey, this is the last one. The second last. It's this day is a year. Here the relation is 0.9, 0.9. Let's start with this one. Where is 0.9 from? This is this side. This one. This bar. This bar. And this one is this bar. This bar. This bar. This bar. So 0.9. Around here, which is 3. Mark 3. 16. This is 16. It's still there. I change this one. This is what? And this one has to be 16, 20.
You make that one 20, that one.
0.9 here. By limit checks, small span and the region. Top 0.03, 1.1. I limit check. And if long tick top, saying top is 0, 1.1. Oh, 0.00 to 1.1. Top. So everything is all about top. Bar spacing. So this is 16. Oh,
First put 12 on that 16 and we see.
yes. There were very many, man. You see, I added 2 here. I added another count here. You understand? I added another count here. Yeah, so it means 2 plus 2, it's going to be 4.
Why are those count and size 2?
Count is the number of bars. Count is the number of bars.
But
Then the size, and this one is the size, okay? Yes, count is the number of bars.
And so why are they on both sides, on 2 sides? Why are they on 2 sides?
I think remember these bars are running all over. These bars are running all over, so any change you make on one can result to the other one. So from here, you click OK. Wait, why are you failing? Go back. These are not supposed to fail, and everything is kawaii. Interactive, then check again. See, no, these ones have failed. Why? Why have you failed? Why? The 122, you change this one to 20. 1.2. What is the failing area provided? Pass weight. Failing ratio is 1.12. And this one is 16. One, this is this one. Yeah, now all the ones are failing. All of them are failing here. Why have they failed? You go back here, design.
You validate.
Let me redesign again. But everything is covered. I think you have understood those things. So this one is to prepare for the online session in the evening. So how do you see when I get some time and again we go through the interactive design? I know you have understood, but not it needs again some time for going through. Yes, so can we handle it after the next after that section? Now that one will be on Wednesday, not tomorrow. Okay.
Yeah.
Yes, so allow me to wish you a nice evening.
Nice evening too.
So how was everything?
So far, very good.
Oh. Is it productive?
Yeah.
Oh, that's good. That's good. So I think next time when we finalize the interactive design, and we shall go to what? Foundation design. There now, you'll be very good to design for a complete structure. But we still have other things maybe to touch like wind loading and seismic. Okay? Yes. Then thereafter practice. Yeah. Then after that we go to TEDs also. We handle TEDs. After handling TEDs, okay. Yeah. So we good to go. Okay?
Okay.
Yes. Thank you so much.
Okay.
Have a nice evening.
Nice evening too.
Yes, you practice this one we have done, and make sure you do some practice. Do exactly what we have done on that structure. Change the necessary things that I told you. Okay. Yes, let's change those things and I send me like after you're done, you will send me and I will see.
So what will I change? Because it's just a